Hello everybody. Today's topic is all going to be looking at units and binary, and this is going to be a new unit which is data representation. This is to do with the OCR GCSE computer science course. My name is Josh, and what I've tried to do with this series is I've tried to give it as little as possible for you to remember, and you can still access the top grades. I'm using my experience as an examiner, a teacher. I was a teacher for a very long time. I was a head of computer science, and also I run a tutoring business, so I still teach lots and lots of students. And how we do this is we look at all of the spec points that could potentially come up. And what we do is we just think about, I use my knowledge and go, these are all of the questions that could come up. And then all you have to do, write down the questions, write down the answers, and then memorize those, and then you can't help but get the top grades. The spec point that we're going to have a quick look at is we're going to have a look at why computers need to use binary. Now, why computers need to use binary is because computers are made up of billions of switches. That's mark number one. They can either be on or off, which is 1 or 0. So you need both of those points to get the top marks on that one. This one is simply just looking at the data storage units and the order in which they go in. Now, what I'd do is this would be a really good one for a flashcard where you just have to try and remember the order of these. So you've got bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte, and petabyte. As soon as you get over a byte, you will see that it's just 1,000 of the thing before. But if you know the order, then that becomes a lot more simple. Finally, the questions that you could potentially come up from this one is they could ask you to order them based on smallest to largest in varying amounts. So I'm going to show you how to convert these all into bits. So 7 bits is just 7 bits. The nibbles, because there's 4 bits per nibble, we do 3 times 4, so that gives us 12 bits. The bytes, there are 8 bits in a byte, so we do 2 times 8, gives us 16 bits. The kilobytes, while this may be a little bit overkill, I'll still show you how to do this with the converting it into number of bits. 8 times 1,000 gives us 8,000. Because we've got 2 kilobytes, 8,000 times 2 is 16,000 bits. Now, the final style of question could be something along the lines of like how many bytes there are in 5 megabytes. Now, what we do is because from our previous slide where we were looking at how the units are stored, we've got 1,000 bytes in a kilobyte, 1,000 kilobytes in a megabyte. So we do 1,000 times 1,000. We take the 6 zeros, put them in before the 1. That gives us a million, and then just simply times it by 5, which gives us 5 million bytes. So people, this is what we are going to do to convert between binary numbers and denary numbers. So denary is just a fancy word for our number system. And I'm going to show you a method which you can employ to convert between the two of them. So this is what you do in the exam. I'll try and do this as small as possible. So we're going to put 1, start off with 1 and keep doubling. 2, 4, we're going to do this 8 times. 8, 16, 32, 64, 128. Now this isn't essential, but I think it's quite a good idea to draw a line in between them. I'm doing it with a nice ruler, but it's just a line in between them. It just helps to separate the content out. Okay, just pop those in there. This is such an important part of your exams, people, because this topic always comes up. It's not going to be exactly, that it could be binary to denary, it could be denary to binary, and there's going to be some other ones I'm going to show you as well. But make sure that you have these really locked down, and then you're going to be able to get, guaranteed that you're going to get some marks on there. So we've got that in there. And then all we do is we write the number in underneath there. So we're going to go 0, 0, oh, sorry, not there, 1, 1, 0. So I'm just writing the number here, 0, 1, 1, 0. Now, the first step is I have to go for all of the numbers that got 1s underneath them. If they got a 0 underneath them, ignore them. We don't need them. So it's going to be 64 plus 32. 6, 9. Okay, then move on to the next number that has a 1 underneath it. So in this case, it's going to be a 4, 0, 1, so 0, 1, and then we're going to put that there. So it's going to be 100. I would always recommend using column addition. You don't get a calculator in the exam. I know that you might want to save a little bit of time and, just sort of try and do it quickly, do it in your head. The reason I say to do column addition, even if you're an amazing mathematician, which I'm sure all of you are, is that you're going to be nervous in the exam. You're going to have a little bit of adrenaline in you. So this just allows you to slow it down a little bit and guarantee that you're going to get these marks. These easy marks, well, easy-ish, this is what you should be aiming for. So the answer on this one was 102. The next one is going to be converting from a normal number into binary. So it's going to be 65. Now, what we have to do is I'm going to show you this method. So we start with the furthest left number, and we're going to say, does 128, is it equal to or less than, does it fit into 65? And no, it doesn't, so we're going to put a 0 there. And we say, does 64, does it fit into 65? Yes, it does, so we're going to put a 1 there. I'll put 64 underneath there, and I'm just going to take them away. Again, using column subtraction. So it's just going to leave me with that there. Then what I do is I go, does 32 fit into 1? Not 65 this time, but 1. So, no. Does 16? No. Does 8? No. Does 4? Nope. Does 2? Nope. Does 1? Yes. And I know I've done it correctly because 64 plus 1 is equal to 65. What I'll do is I'll put some questions up as well so that you can have a little practice with these. But yeah, these are the methods. Practice these lots and lots of times and you'll be absolutely fine with these.